What's up, guys? What's up, everyone? Don't want to try to hear live ones today. Hey, good morning, guys. Do a quick audio check. If you can hear me, give me a thumbs up. If you can see the video, you can see stuff happening, give me a thumbs up as well. If you can't, just tell me what you can't see or hear. Okay, looks like everyone's good with hearing and seeing. Thank you guys so much for being here on this Friday morning. Man, these weeks are flying by. In addition to you hearing me and seeing the image, we will also let you see me today. So what is up, everybody? I hope you guys are doing extremely good today. Everything's going good. So I thought you would, you can at least see me. I can't see you. In my opinion, that is a good thing. It may be a good thing for you not to see me either. But hey, it is what it is. So we can, yeah, even in uniform, that's exactly right. And so yeah, this is when you know you have too much time on your hand, when you get real creative with YouTube videos. Let's just jump into this. Actually, well, no, I'll ask you that question a little bit later. But any questions on the last homework? I think that last homework was 5.6 homework. So before we get going too crazy today, any questions over the homework 5.6? And we'll make me a little bit smaller so I don't have to be so big on the screen. I don't want to take up the whole screen. All right. So it sees that Abby said question 5. Okay, so question 5, and here's what it's saying. Tell your mom I said hello, Caitlin. Tell her she can join anytime. Okay, so Elena's saying that her question number 5 didn't line up. Okay, so cool. We'll work number 5 real quick. So looking at number, are the answers on the back? Okay, yeah, cool. All right, so looking at number 5. If I'm going to work this out today, let's look at it. And the answer key could have been wrong. Who knows, you know? So if I'm going to do the inverse of this, we know that that's going to be x equals the 5th root of negative y plus 3. That's where I'm going to start at. And then from there, I'm then going to take the 5th power of both. So take the 5th power of this, take the 5th power of this in order to isolate y. So I have x to the 5th power is equal to, that cancels with that, negative y plus 3. I then subtract 3 from both sides and get x to the 5th minus 3 is equal to negative y. I then divide the negative out and get y is equal to negative x to the 5th plus 3. Is that what you found for g prime of x? Or not g prime, my goodness, I'm in calculus. The inverse of g of x. Is that what you all found? Negative x to the 5th plus 3? Okay, cool. So then let's graph from there. So if I'm going to graph this first one right here, okay, if I'm graphing this right here, uh, what did it, all right, let me see what it says on the same thing, right? Okay. So same, our inverse is the same. So then let's, is that what you're, I think you guys are talking more about the graphs, I assume? Okay, cool. So looking at the graph of this first one, plus 3 on the inside is going to go to the left 3 times. Okay? So I'm graphing this top one here. Plus 3 is going to go over here. And it's going to go left 3, and I'm going to put a point there. And I'm looking at this. I'm going to look at it on the calculator real quick. Oh, okay. I think I see what it is now. Okay, because obviously we don't have anything over here with this negative 3 right here. They have it as positive 3. Give me 1 second. Okay, so sorry, it took me a second to kind of see what was happening here. All right, so it's not an issue. You need some prior knowledge though. Okay, so when I'm going to graph this right here, okay, when I'm graphing g of x, so we would naturally think 3 is on the inside, so it goes to the left 3. That's what you've been taught, okay? And that is true. When you have a plus 3 on the inside, that goes left 3. But your issue lies with this negative right here, okay? The issue lies with the negative. So, who remembers what it is when you have a negative on the inside? Now, negative on the outside is a reflection of the x-axis, going back to chapter 1 functions. But if you have a negative on the inside, what is that a reflection of? Yes, Elena. It's a reflection of the y-axis. Not flip upside like it's so normally. I'm going to do this with a pencil so I can erase it. Normally we would think this graph. So if we did that, normally the fifth root would go 1, 1, and then like it'd be looking something like this. I'm going to do this in a pencil. And then something like this, right? But now but since that is a negative on the inside, that means that this graph right here actually reflects across the y-axis, okay? Now, you may say, well, how in the world do I actually work that? Couple different ways. You can just make an XY table of that g of x right there. Make an XY table and then just find your values and plug it in. Or if you think about this, okay, I always say this. Turn your line of reflection, actually here, our line of reflection is the y. So everything over here has to mirror everything over there. So it actually be, the 3 would be here because that's a reflection of the x-axis, right? And then now it's going to go down like this. I want to make sure I'm doing this right. Yeah, down like this and then going that way. And then it's going to go out like that. There. Now, what I told you was, if you ever want to see a true reflection, have your line of reflection to be vertical. So our line of reflection here is the y-axis, and it's vertical. You can see that true reflection. Okay? So this side and this side are mirrored. But of course, we don't need this one because that is the one, that's a positive x here. So it actually would just be that line right there. I'll stop here. Does that make sense why that is like that? Maddie, that's actually a good question. You don't have to graph the first one. The first one just it can help you. It can help you. It can kind of like guide you into knowing, like where to put the reflection point, and it should be a mirror over the y-axis. I haven't seen inside the x in a long time, or inside the inside negative in a very long time, probably since chapter 1. So that's why it took me a minute, and then I realized, okay, they're just reflecting it because of that right there. Okay, so you feel free to do. I mean, you can graph out the first one, and then say, all right, I just need to reflect across the y now, so make it look like that, and that should be, an understanding of that. Sorry, I'm having a conversation with my wife. Muy bien. Okay, so totally up to you there. I'm going to kind of mark this now. That should look like that. And then my other one, negative x to the fifth plus 3. So I'm going to go up 3 right here. And then negative x to the fifth normally does this number, but it's negative, so it reflects across. Reflects across the x. So here and here. And then that would look like going up and going down. So that's just like graphing like x squared. X squared is like this, but when it's negative, you flip it across the x. Same thing here. X cubed normally does that, but negative x cubed we know goes quadrant 2 and quadrant 4. And then, of course, from there, I can have my I can line my y equals x up, and I see that that's there. Turn that line of reflection vertical, and I can see that true reflection. I'll get to number 6. So Maddie said, so does that mean it reflected across the y? Correct. So the inverse reflected across y because it's on the inside. This reflected across the x because it's on the outside. So normally it would look like that, and you basically just flipped it across the y. We all good on number 5? Thumbs up, smiley face, or any questions that you may have on it. Okay. So Abby said 5. Lucy said 4. Lucy, you still want to see 4, correct? Just making sure. Okay, cool. Looking at number 4. Yes, Caitlin, I actually do. It's not like a real green screen or anything like that. It's just like a piece of green fabric um, that I can obviously kind of dim down a little bit. Kind of gives the effect just kind of seeing me. All right. So I guess I could put if we wanted to, I guess I could put if we're really getting crazy. No, I better not go. I better not go too crazy. All right. So looking at number 4. Sorry, Lucy. So g of x equals negative x minus 3 cubed, and it wants the inverse and graph the inverse and the function. So that would be x is equal to negative quantity of y minus 3, and that's going to be cubed. Now, the first thing that I would do, the very first thing that I'm going to do is I would divide both sides by negative first. Negative 1, negative 1. Cancels, cancels, and I get negative x is equal to y minus 3 cubed. From there, I'll do the cube root of both sides to get that cube off. Cube root and the cube cancel, and I'm left with the cube root of negative x equals y minus 3. And then just add that 3 to both sides. The cube root of negative x is plus 3 is equal to y. And I'm just going to write it like y equals the cube root of negative x plus 3. Man, these were some pretty tough ones. I'm not going to lie. All right, so then going from there, I need to say the inverse of g of x is equal to the cube root of negative x plus 3. And now I graph both of them. Now, to graph the first one, to graph this one first, okay, I'm going to say negative 3 on the inside. So that goes to the right 3. That goes to the right 3. And then I take care of that. And then I just have negative x cubed. Now, x cubed normally does this. Right 1 up, 1 right, 2 up, 8. And then it kind of takes on that. But since it's negative, it's reflected across the x-axis. So then I just go left 1 up 1. I just do the opposite. So it should be looking something like this. Something like this. Okay? The other one is plus 3. So I go plus 3 here. That takes care of that plus 3. And then it's the cube root of negative x. So the cube root of x normally does up 1, right 1. And then we would make this curve right here. That's just the cube root of positive x. But the cube root of negative x would go the opposite way. So that would be right 1, down 1. Up 1, left 1. And it should be doing this number right here. And that looks like I have, if I was to put my pen down for y equals x, that looks like it has symmetry across y equals x. So right here, actually, yeah, this is actually pretty funny. This is a green pen, and you actually, obviously, you can't see the tip due to it being green. Here's a purple one though, and you can obviously kind of see that that it's purple. So, yep, got that green screen behind me. Of course, I don't know how to show you on pens because I'm opposite of what I'm actually doing. So, yep. Am I right? Okay. Let me see. Does that make sense, Lucy, now? And then 4, 5, 3. Christina, do you need to see 3, or are you good? I thought I read where you said you're good in there, but I'm happy to work it if you need me to. Okay, cool. So I think some of you said you wanted to see 6. Elena hasn't stopped saying I want to see number 6. So looking at number 6. There we go. Looking at number 6 here. So our first step is to change it to its inverse. So change x and y. X equals the 5th root of y plus 3 over 2. So I switch those. Okay. My next step is to multiply both by, or raise both to the 5th power. That's x to the 5th power is equal to, cancels, y plus 3 over 2. Multiply both sides by 2. 2x to the 5th equals y plus 3. And then 2x to the 5th minus 3 equals y. So y equals 2x to the 5th minus 3. I'm assuming that's what you all got, and then the inverse of g of x is equal to 2x to the 5th minus 3. And so your question was how to graph g of x. I think that's what your question was, right, Elena? I just saw it. So, all right. So here's the thing: when you're looking at something like this, in my opinion, we really haven't looked at fractions inside of here. So that kind of presents a little bit of an issue. You could think about this as x over 2 plus 3 over 2. So we should go to the left 1.5. So on the graph, it should be somewhere over here, okay? But if worse came to worse, I would just plug values in and see what you would get. Now this may require a calculator, okay, to kind of see what you're dealing with here. And I would be fine, especially on something like this. This is pretty heavy stuff. So even if you have 3 divided by 2, the 5th root of 3 over 2 is 1.08. So 0 and 1.08, so that'd be like right here for g of x. And then just type in another one. What's the 5th root of 2? If I was to type in a 1 there, that'd be 4 over 2. So the 5th root of 2 is 1.4. So 1 and 1.4. So it's seeming like it's kind of going that direction. I think right here, it's going to do the 3/2, so then just go to -1. -1 plus 3 would be 2. And so that would give us the point. So if we type in a -1 right here, -1 plus 3 is positive 2. 2 over 2 is 1. And then, of course, the 5th root of 1 would be 1. So 1, -1. I think that's probably going to be our turning point. And then go to -2. -2 plus 3 is obviously 1. And then the 5th root of 1/2, 1 divided by 2, would be equal to 0.87. So so if I type in a -2, that's 1/2. So then that's there, 0.87, not quite 1. Hold on, let me see what this graph is doing. That's not right. Well, I don't know what that deal is. So let's graph the other one real quick. That one should be right 1 and up 2, down 1, left 2. So we know this is doing this right here and that. Okay, so that takes care of that one. But this one is the one that's, I guess, throwing us off. So I would make a true x. Let's make a true xy. I must be getting something mixed up here. So if I punch in a 0 there, 0 plus 3 is 3 over 2. So the 5th root of 3/2, and if I'm just going to use a calculator for that, the fifth root of 3 over 2 would be 1.08. If I type in -1, -1 plus 3 is 2. 2 over 2 is 1. The fifth root of 1 is 1. That's what's throwing me off, is this right here. Because they don't, do they have us going across -1? They don't. Oh, I see what you're saying. Oh, -1, 1. My bad. Sorry, I'm not paying attention. I guess that's what I get. Okay, so then if I kept going, there you go, Maddie. Thanks for stepping up to the plate. So then if we kept going on with the, then if I kept going, -2 is 0.87. That's where I got that. And then we can kind of see, again, if you had this graph, if you think about, you just got to like do the opposite of what it's doing. And then obviously we could keep getting these points just by punching in -2 plus 3 is 1/2. The fifth root of 1/2 is 0.87. So -2 is 0.87. Type in a -3. That's 0, which is going to be 0. So at -3 is 0. So we know it's doing this right here. And then you type in -4. So that's the way I would do it. Just make sure you plot right and don't make the mistake that I made. -4 would be -1/2. So the fifth root of -1/2 it'd be -0.87. So then it just starts that downcline again. So sorry that was slow and horrible, but kind of seeing it. And then obviously I would have, if I kept going with my line here, I would have that symmetry across y equals x. All right. So to answer Elena's question, I would just set up an XY table. Really no shortcut. I mean, just because it's all these numbers are being divided by 2. So you would have to think I'd have to divide what I normally do by 2. So that kind of makes it a little bit nasty. So that's where you're going to get more into those decimals and stuff. So I would just make XY and then graph it from there. And then make sure it reflects across y equals x. Any other questions on lesson 5.6? That's what I want, Maddie. I don't want you to talk at all. This is just like class. So if you're good, give me a thumbs up. If you're ready to go to the study guide, something like that, type something in the chat box. If you're good, ready to go. That's exactly right, Abby. Hey, my goal is to keep this as normal as possible. You see me, I don't see you. That's normally the way it works. I really don't even pay attention to you guys. I just go up there and teach and just, go with the flow. So, all right, so let's jump into the study guide. Hey, you may need a sheet of paper. Yeah, that's the part about Zoom that I don't like. That's what I don't like. No, I'm not a hater on Zoom. I'm just more used to YouTube. And I would be. You all said Miss Ray forgot to hit the record button. I would definitely forget to hit it. And then if I forgot to hit record, it would be a nightmare. Literally, it would be a nightmare. And that would be something that I would do. I would like literally forget to hit record. And then I'd have kids saying, "Hey, I didn't make it to class, but I don't know what to do. What do I do now?" So it would be a nightmare for me. So it's just kind of YouTube's just easy, it's kind of there, and I know they're making Zoom easier by the day. Actually, stocks for Zoom are going through the roof right now because obviously everyone's using it due to the social distancing. So um, it's okay though. That problem is not that big of a deal. I was just off for maybe a minute or so, and then I looked at the chat. Um, so, um, let's look at chapter 5. Now, you may need to get a sheet of paper out, guys, because I didn't give us too much room. No, I didn't do it on purpose, but just trying to save paper. You may need to get a sheet of paper out here in order to do some of these problems. Maybe not all of them, but some of them. You'll need a sheet of paper. I did not put stock in Zoom. I've never heard of Zoom. I have never heard of Zoom before all this went down, so that's why I wouldn't put my stock in Zoom. A pandemic had to happen in order for me to hear about it. So a pandemic that hasn't happened in the history, besides going back to like the 19 teens, when when obviously that flu was around. So hadn't seen it in a while. So yeah, I kind of play pretty conservative. Now, if you're talking Apple, that would be a good stock to invest in, but the shares are so expensive right now, it's crazy. All right, so jumping in here to chapter 5 study guide. All right, so number 1, and it says write each expression in radical form. So here's what you just need to remember, that the denominator is the index. So we need to say the fourth root of 10b. And remember that 7 can go on the inside or it can go on the outside. Either way works. So this is also equal to 10b, not 16, 10b to the 7th. So on the inside or the outside works. Number 2 says the square root of 10v cubed. So take that to exponential form. So that would be 10v. And remember our index, if there's not an index, it's 2. And then that would be, or sorry, not 10 raised to the v. 10v raised to the 2 or 3/2 power. Your index is your denominator. Your index is your denominator. And make sure you put that in parentheses because it's not just the v to the 3/2, but it's the 10v to the 3/2. Yes, Caitlin, my son would be proud saving trees. What's so funny right now? My son is like literally on a Zoom conference with with one of his friends from school because it was his birthday party, and obviously with nothing happening. So the kid's mom just said, "Hey, can we get all of our kids on Zoom just so they can all say something?" So he's actually on a Zoom conference right now as we speak. So my daughter has watched Frozen 2 literally 27 times. She's a big Toy Story 3 fan. She's watched that probably about 17 times. So, unfortunately, while me and Miss Hypock are working, she gets to watch some TV. But yesterday, actually the past 2 days, since it was so nice outside, we gave them the days off of work and reading. Or we did some reading outside, but we gave them the day off, and we kind of just spent the days outside because it was really, really nice. So, all right. So, jumping down to number 3, solve each equation. All right. So, like I said, I didn't give us too much room here. That wasn't on purpose or anything. I wasn't trying to give us room. But looking at this, I have 1,000 is equal to 44 minus 2x raised to the 3/2 power. All right. Now, couple different things we can do here. We can change this to radical form and say 1,000 is equal to the square root of 44 minus 2x and all of that cubed. All right, so from there, I would then do the cube root of both sides in order to get that cube off of there. Cube root of both sides. The cube root and the cube cancel there. And then the cube root of 1,000 should be 10. So 10 is equal to the square root of 44 minus 2x. I then square both sides and get 100 is equal to 44 minus 2x. I then subtract 44 from both sides. Get negative 2x is equal to 100 minus 44 should be 56. Divide both sides by negative 2 and get x to be negative 28. Okay, so we got x is equal to negative 28. All right. Going to there, let's look at number 4. Negative 3 is equal to the negative quantity of 2v minus 336 to the 3/4 power plus 5. I would subtract 5 on both sides first. Sorry. Get that to be negative 8 is equal to the negative quantity of 2v minus 36 raised to the 3/4 power. Divide both sides by negative 1. Cancels, cancels. That's positive 8 now is equal to 2v minus 36 to the 3/4 power. Okay, I'm going to rewrite this in radical form. So rewrite this right here in radical form. That would take me to the 4th root of 2v minus 36 to the 3rd power. I then do the cube root of both sides. We know that becomes 2, and that becomes the 4th root of 2v minus 36. Then I have the 4th root, or take the 4th, raise each side to the 4th power. 2 times 2 times 2 times 2 is 16. Is equal, that cancels with that. 2v minus 36. I then add 36 to both sides. Cancels. That's 52 equals 2v. Divide both sides by 2, and you should get v to be equal to 26. So number 4 would be v is equal to 26. All right, jumping over here to number 5, when we have radicals and we're simplifying them, it will actually be next Thursday, Caitlin. And yes, there will be a time limit, Maddie. Okay, look at number 5. What do I do when I have radical 12 times radical 15? I would multiply what's on the inside. So say radical 12 times 15. And 12 times 15 would be 180. So radical 180. Now, I need to get my paper back over here because 180 can be simplified. What perfect square root? Someone type that in the chat box. What perfect square root will go into 180? What perfect square root will go into 180? Elena says 9. Is that the highest one that'll go into it? So 36 is what Maddie says. 100 won't go into 80, right, Caitlin? So that should be radical 36 radical 5, which is 6 radical 5. So that is equal to 6 radical 5. Okay? All right, then jumping over here to number 6. So looking at 6, I'm going to copy that down. 2 radical 10 and negative times negative 5 radical 6 plus radical 2. Distribute, distribute. That should take us to negative 10 times radical 60 plus that times that would be 2 radical 20. And then we need to simplify the square root of 60 and simplify the square root of 20. Square root of 60, what will go into 60? What perfect square root will go into 60? Should be 4 and 15. So radical 4, radical 15. And that's negative 10 times 2 times radical 15. So then that would lead us to negative 20 radical 15 plus 2 radical 4 radical 5, which is 2 times 2 radical 5. So that would be plus 4 radical 5. Come here, Lynn. Come here. Lanny wanted to say hello to everybody. Say hello.
Hello.
You gonna wave at them? Let's see if they respond to you. It'll go right there if they respond to you. See what they say. Christina says hi. Christina's a little bit different.
That's funny.
That is funny, isn't it? Abby says hi. Abby's a little bit. She's a little bit weird too. So.
Oh, I get it.
There's Matt. See, now they're all saying hello.
Ooh, that's so funny.
All right, love you, man.
Love you too.
All right. So that is number 6. A little break in the action there. Going over to number 7. You hate to see it, Karen. I didn't mean to call you Karen. I meant Christina. Oh, goodness. I'm sorry. All right. So now looking at number 7. Radical 3. Radical 3 plus radical 5 times radical 3 minus radical 5. Okay. Now, so I would have to FOIL this unless you caught what else it actually is. Does anybody know what this actually is right here? What is this called when it's radical 3 plus radical 5 times radical 3 minus radical 5? Anybody remember what that's called? Christina, you're normally the vocab person. Anybody? No. Complex conjugates. Those are complex conjugates. You could say a difference of squares as well. That wouldn't necessarily be like totally wrong. Because it right here we do have this, but difference of squares deal with squares like x squared and y squared. This is actually 3 to the 1/2. So it's a little bit different than, I see what you're saying by difference of squares, but they're actually complex conjugates. And if you all remember that shortcut, it's a squared minus b squared. So it'd actually be the square root of 3 squared minus the square root of 5 squared. Well, the square root of 3 times the square root of 3, the squares cancel, right? Square and square root cancels. So 3 minus 5 is actually negative 2. So my answer is negative 2. But that's complex conjugate. That's pretty easy. But let's FOIL it, okay? We need to FOIL it just in case you see one on your test that's not a complex conjugate. So FOIL, go first. Radical 3 times radical 3 would be 3. Abby, what did you say? You said won't they cancel? I don't. I mean that's kind of a vague answer, but I mean if that's what you had in mind, more power to you, Abby. So radical 3 times radical 3 is 3. Go outside. That would be negative radical 15. Go inside. That would be plus radical 15. And then that would be minus radical 5 times radical 5 is 5. That cancels with that. 3 minus 5 would be negative 2. So same answer. So number 7 is negative 2. All right. Jumping over here to 8. Oh, I'm sorry. That's actually a 15 as well, Christina. So the first and then outside radical 3 times negative radical 5 would be negative radical 15, and then inside radical 5 times radical 3 would be positive radical 15. Radical 15 plus, or negative radical 15 plus radical 15 would cancel, or just simply give us 0. And remember, treat these like variables. So negative x plus x would cancel as well. Okay? All right, looking at number 8. I think we can actually work number 8 on our paper. So 3 radical 6, that actually can't do anything there. Can't simplify that. So that's going to stay 3 radical 3. Because I can't pull anything out. Or excuse me, not 3 radical, 3 radical 6, right? All over. But now that 5 radical 50 can change because we know that 25 will go into it. Okay. Actually, let me put the brakes on here. Of course, I hadn't looked at this in a little bit of time. They're going to hit us. Let me think. Okay. Actually, here's what they're going. This is going to be a little bit different. Okay. So let me work this on paper, because after looking at the answer, it's going to have us do something else, and I think it'll be a little bit easier for you to see it this way. So 3 over 5, 3 radical 6 over 5 radical 50 could actually be written like this: 3 over 5 times radical 6 over radical 50. Now, what you need to know about this right here, okay, and I don't know if we saw one like this on the notes. That's why I'm glad we're doing this now. This would go to this: 3 over radical 5 times the radical of 6 over 50. So when you have a radical in the numerator, and I can't remember if we did that in the notes. It was so long ago. When you have a radical in the numerator and the denominator, you can just make the whole fraction that. Okay? But now that simplifies to this. 2 goes into both of those. 2 goes into that 3 times. So that's radical. So still we have our big radical. Radical 3 over 25. Okay? But now we then take it back to just individual square roots. and say 3 over 5 times radical 3 over radical 25. And then from there we have 3 radical 3 over 5 times 5, because radical 25 is 5, and then 5 times 5. So that would be 3 radical 3 over 25. So if you would have started the route that I was about to take us on, we would have got close to the answer, but we would have but you would have to simplify again. So that way would have worked, but this way I feel like is much easier to see. Instead of simplifying and then doing this, I think it's just best to do it from the beginning. So this is 3 radical 3 over 25. Okay? Just a few more left today, guys. So looking at number 9. Nine's actually, I don't know how 9 got on here. But remember the whole thing about rationalizing denominators, meaning that you don't want to have radicals in. Rationalizing denominators. So you don't want denominators with radicals. But what's so easy about this one is that that's not really a radical. We can just say 2 plus 2 radical 3 over 5. Nothing can simplify, so that's actually my answer there. So that one's kind of easy. All right. Give me a... okay, great question, Lana. Lana says, why not 4 radical 3? I cannot add those two together because that's 2 times radical 3. Okay? It's like, remember, treat radicals like they're variables. So that's almost like saying this, 2 plus 2x. I cannot combine 2 plus 2x because they're not like terms. And another way to answer that is to say, type it in a calculator. What's 2 plus 2 radical 3? 2 plus 2 times radical 3 is equal to 5.4. But 4 times radical 3 is 6.9. So obviously they're two different things there. Okay, good question, Elena. Okay, so then jumping over here to number 10. I think I have enough room right here to work number 10. So at number 10, again, what you want to do is you want to, with number 10, what we're going to have to do is get these radicals out of the denominator. It's called rationalizing the denominator. So I need to multiply bottom and top by the complex conjugate. All right, so here we go. We distribute, we get 4 radical 5, and then we distribute that. 4 times 2 would be 8 radical 3. I'll explain later, Abby. all over, and then we just have to FOIL this. Now again, these are complex conjugates, so we could just say Maddie says, what was the one shortcut we do for the denominator? That's what we did while ago with the that's what we did while ago with the complex conjugate. It's just a squared minus b squared. So you could FOIL that out, or you can use the shortcut right here, a squared minus b squared. So that would be radical 5. I would probably use this. Radical 5 squared minus 2 radical 3 squared. That would be 5 minus, and basically so right here, when we do this, you have to attach this as a power of a product, so you have to attach that 2 to both the 2 and to this. So that would be 4, or let me write that out. That would look like this: 2 squared and then radical 3 squared. And you're multiplying those two. So it's 5 minus 4 times 3. 5 minus 12 would be negative 7. You get the same thing if you FOIL it out. And then this would be my answer. Now, if you look on your answer key, the numerators are both negative, and this is positive. That's the same thing, okay? Same exact thing. The negative can be in either one. It can be in the denominator, or it can be in the numerator and this be positive. So either way works there. All right, so then let's look at number 11. So number 11. So what I need to do here, and I'm just going to write this out, is multiply this times 4 plus radical 2. Multiply this times 4 plus radical 2. All right? So when I FOIL this numerator, when I go first, I'm going to get negative 16. I'm going to get negative 16. And then I go outside. I'm going to get negative 4 radical 2. And then I'm going to go inside and get plus 16 radical 5. And then go on the outside and get plus 4, go last, go plus 4 radical 10. And that's all going to be all over. We just need to do our shortcut here, a squared minus b squared. So 4 squared minus radical 2 squared. That would be 16 minus 2, which is 14. So this is all over 14. Now, notice that 2 can go into all of this, okay? 2 can go into it all, so I just reduce everything by 2. So negative 8 minus 2 radical 2 plus 8 radical 5 plus 2 radical 10 all over 7. And that would be my answer. Elena said not 5. You want to? I'm not sure what you mean, not 5, Elena. Yeah, I simplified. I took everything down by 2. These are just like, imagine these being like X, Y, and Z. Since they're not alike, you can't combine anything. And I just canceled all of these by 2. 2 goes into that -8 times. 2 goes into that twice. 2 goes into that 8. 2 goes into that twice. 2 goes into that 7. And you would simplify radicals, but none of these radicals can be simplified. Okay, cool. Not a problem. So looking at number 12, identify the domain and range of each, then sketch the graph. Okay? Identify the domain and range of each, and then sketch the graph. So if we're looking here at this, we know our shortcut. That -1 means go down 1. That -2 means go right 2. So down 1, right 2. That takes care of that, and it takes care of that. And then I go up 1, right 1, right 4, up 2. 1, 2, 3, 4, up 2, 1, 2. And it should be a graph looking like that. All right. And then domain. How about it? I don't know who's in here with me right now, but let's go. Bernice. Bernice, are you still with me? Bernice, you still with me? Bernice, if you're still with me, do the domain, and then Christina, you do the range. Bernice, domain. Yeah. All right, Bernice, give me the range, and then Christina, you do the range if you're still with me. Christina says oh yeah, Christina's doing the range. So -1 and -1 is included all the way to infinity. Good. And then Bernice said, and that of course has a bracket on 2 because 2 is included all the way to infinity. All right, guys, that is 1 through 12. So practically that's half of it. We have the back side, okay, which it shouldn't be terrible, which is not going to be bad. That we will complete next week. Today's Friday. We will complete it next week. unless, this is a big unless we want to complete it right now. If we complete it right now, this is just an option to you all. We can either finish this right now or just come back on Monday and finish it. You all tell me what you would like. Everyone's kind of done. Okay, cool. Or at least Christina and Caitlin are done, and we know Christina is a diva, so we don't want to upset her. That's right. No, I totally understand, guys. I'm done for the day as well. I'm sure you guys have been extremely busy. All right, so what we will do, we'll do Monday. I'll send you out a schedule here in a little bit. We will do like Monday or something like that. We'll do Monday at like 11 a.m. I'll send that schedule out to you. Then, just kind of following up, what else we'll do the, I'm going to let you take, or actually, I'll just explain to you Monday what I'm doing. Or actually, you're going to see it on the schedule. So after we get done with the study guide, I'm going to have you take a practice test before you actually take your test on Thursday, just so you see the format. I'm going to give you a quiz grade for it, but I want you to see the format of what it's going to look like before you actually take your test. It'll be maybe like 5 to 10 questions. They shouldn't be too hard, multiple choice, so you see what's happening and you know exactly kind of the format of everything. Because when you get there Thursday, you are going to have a time limit. It's going to be a little bit different, so I want you prepared for it. Does that make sense to everybody? No, yeah, so you will actually get a grade for it. You are going to get a grade for it. It's just whatever grade you make on it. So it's whatever you get on it. Yes, the test will be multiple choice. Correct. But it's in terms of like what your grade will be on it, it will be no, okay. So let me clear any kind of confusion right now. I'm going to give you a practice test. It's going to be due Tuesday at midnight. There will be 10 questions on it. Each question is worth 4 points, and that will be for a quiz grade. You will have 3 attempts to take the quiz. Again, I'm trying to warm you up to the format of the quiz. So from there, you can know what it's like on Thursday. You know what to expect. You know what it's going to look like. Then on Thursday, and then your score, that 40 points that you score there will literally come from whatever you score on that practice quiz. But you'll have 3 attempts, so it should be pretty simple from there. But then I'm just trying to set you up for your test on Thursday, which will be worth 100 points, 25 questions, multiple choice, and then you'll see on there, actually, and what you score on there is what you score. Does that make sense to everyone now? And I will type that out in our message when I type that out. Caitlin's good. Not sure yet on the time. Not sure yet on the time of the actual test. The practice test will not be timed. I'm thinking it'll be plenty of time though. I'm thinking 2.5 to. I'm thinking literally 120, 150 minutes, something like that. So 2.5 hours. So it should not take you 2.5 hours because it's multiple choice. So you, but not enough time that you just can do whatever you want. And I'll explain more about the practice test, what to expect, and what to expect from the test. So it's all in Canvas. So you're not like, man, what in the world's going on? Or, because you won't probably have the same questions. You will in the practice test just to warm you up, but on the actual test, not everyone's going to have the same questions, so it may kind of mess with you a little bit. Any other questions? If you don't have any other questions, you guys are free to be dismissed. We'll finish this up. I'll see you Monday at 11 a.m. For the YouTube live session over the second part of the study guide. If you don't have any questions of me, give me a thumbs up that you're good today. Today it was hard, strenuous, honest. A lot of stuff to go through, but give me a thumbs up and then you're good to go. Thanks so much for being here with me today, guys. I appreciate you all being here. Have a good day. Yeah, see you all. See you all. Good day. I'll be here for a little bit if you want to ask me any questions. Good day. Good day.